So this is method 2 of simplifying a square root. Remember, when we simplify a square root, this means that we do not have the decimal. Our answer will include a radical unless we're simplifying a perfect square. So this method 2, I call it the upside down birthday cake method. It's really just the method that uses the prime factorization of our radicand to figure out how many perfect squares are factors of the radicand. So your prime numbers, knowing them is going to be really important. So 2, 3, 5, 7, 11, 13, and so on. Again, a prime number is a number that its only factors are itself and 1. So the way we're going to work this is we're going to write our starting number as the first layer of the cake. So our radicand 180 is our starting number, and the cake really is just our way of figuring out what are the prime factors of this number. So we always start with the smallest number, and that's 2. And you check to see, does 2 divide 180? If you need to, use the calculator. But 2 does divide 180, and that's going to give me a 90 times. And so we're going to continue with 2 until 2 no longer goes into our layer. So 2 also goes into 90, and that gives me 45. Now, 2 will no longer go into 45, so we go to our next prime number, and that's 3. So we're done with the 2. We're going to try 3. Does 3 go into 45? Yes. It goes into 45 15 times. And we continue with 3 until it no longer goes into our layer. So 3 divides 15. That's 5 times. Now at this point I know 3 no longer divides 5, so we're done with 3, and we go to 5. 5 divides 5 one time, and this is where we get our birthday candle. So the goal is to factor until you get to this 1. So we just completed steps 1, 2, and 3. We'll repeat this process again until you get to the candle, which is really just the 1. Now, because we're dealing with the square root, that means that looking for pairs of the same number, we're going to circle pairs of the same number on the outside. So if we look here, I have a pair of 2's here, and I have a pair of 3's here. This tells me that I have a perfect square of 2 squared, and I have a perfect square of 3 squared inside of 180. And so any number circled will get multiplied together and placed on the outside. So we're going to have 2 times 3 on the outside. And then any number not circled gets multiplied. Well, the only number not circled is this 5, and that's going to go inside as our radicand. So 2 times 3 gives us 6, square root of 5. And we can check our answer, even if our calculator doesn't simplify it with this nice 6 square root of 5. If I type in the square root of 180, I'm going to get a decimal, 13.416. So this is an irrational number. It goes on forever. And if I were to type in 6 square root of 5, I'm going to get that same exact answer. So I know 6 root 5 is equal to the square root of 180. So on the next page, I have another problem that you can try. Pause the video, simplify the square root of 496. Pause the video, see if you get the same answer as I do using the upside down birthday cake method. All right, so here I'm going to do my work. We start with 496. It's even, so I know 2 goes into that. And so 496 divided by 2 gives me 248. Once again, that's even, so I know 2 goes into that. So I'm going to divide 248 by 2. That gives me 124. I know 2 goes into that because that's even. That's going to be 62. 2 goes into that because that is even. That is 31. Now we're stuck at 31. Now if I think of 31, 31 is a prime number, and so there's going to be no other number that goes into it other than 31. So we found the prime factorization of 496. I'm going to circle pairs of the same number. So that's 2 and another group of 2, which means I'm going to have 2 times 2 times the square root of the only thing that's not circled is 31. Oh, I forgot my candle here. 2 times 2 is 4, square root of 31. And so let's just check. Let's clear that. Square root of 496, 22.271, 4 square root of 31 should give us the same exact answer, and it does. And so this is using the upside down birthday cake method. It's really just finding the prime factors and then circling your perfect squares that we can take out of our Radican.